how to animate GPS tracks in Tableau Desktop. There are two inputs that you need. You actually need to create the GPS track by doing something. In our example today, it will be motorcycling data. And the second thing that you need is Google Maps timeline data. So we'll cover how to generate Google Maps timeline data. The output is going to be an animated GPS track rendered in Tableau Desktop. The mechanisms needed in order to do this activity are a smartphone, Google Maps with location tracking activated. You'll need a GPS tracking app like Rever.co, a desktop, Google Maps on desktop, Notepad++, a spreadsheet, and Tableau Desktop. The only control in this process are the constraints that you'll experience using GPS data. So let's get started.
We're going to break this activity down into 3 distinct steps, each with their own inputs, outputs, controls, and mechanisms. We're going to first gather the data, which will produce our Google Maps timeline data. We'll then prep that data in order to produce tabular data in a G-sheet. The final step will be to visualize that data from the G-sheet and create an animated GPS track visualization. Gathering track data with your phone is easy. You'll first need to set up a few settings on your phone. The first is to make sure that you've got location enabled on Maps. So let's go to Maps, click your icon, your timeline, Settings and Privacy, and you'll just want to confirm that location is on. The day that you want to record an activity, you'll need a GPS tracker to get the most accurate GPS coordinates. By default, Google Timeline only records locations by cell towers. An app that I use is Rever.co. Most of these apps, all you have to do is open and hit record. Once you're done recording, you can confirm that the tracks have been recorded in your timeline by going back to Maps, looking at your timeline, and examine the day.
Now that we have our Google Maps timeline data recorded, we want to convert that data into tabular data in order to use it in Tableau. Let's go to Google Maps on desktop to look at our data. In Google Maps, to get to your timeline data, navigate to the hamburger and choose your timeline. The initial view you see will be the full history of all the destination data in your Google Maps account. If we want a specific day, we'll find that day and navigate to it. We can see that the GPS was activated. A good line is now there to represent the full set of tracks. In order to get to this data for use in Tableau, we can download the KML file. We'll save this file to a convenient location. KML files are formatted in the XML file format. We can see this if we open the file in a tool like Notepad++. Let's open our KML file. On first inspection of the KML file, it looks a little messy. XML is well structured, but the application needs to know that it's XML in order to structure it on your behalf. Notepad++ contains plugins which allow you to act on the data in your file. The plugins that you'll want to install are called XML tools. To install applications, simply go to Plugins Admin, search for the tool, click, and install. In this case, we want to use the XML Tools plugins feature called Pretty Print. This is going to structure our data so that it's more readable to a human. Right away, we can see the tag, beginning and ending tag features of the XML file. What we're interested in are the coordinates data. So the coordinates are included in the coordinates tag, but that's not easy to work with. What we want to do is we want to convert this long string into tabular data. Let's prep a spreadsheet in order to convert this string data into tabular data. Here in Google Sheets, you can see that I've already prepped a spreadsheet and have been working with some of the GPS data. Let's make some new entries. Let's first grab the description of this coordinate data. The description serves as a unique identifier of this batch of coordinates. There may be multiple batches for the day, so you'll want to uniquely identify each of the sets of coordinates here for each line segment that's going to appear on your visualization. Let's copy the description, paste it into our spreadsheet. The next step is to copy out the coordinate data. Now we're only interested in the coordinate data. We're going to create a separate notepad file, paste. Now to convert these to separate records, we'll replace the spaces with a control character. Here we're going to enter in a space, and a carriage return is known as a /n special character. So we use /n and replace all. Select all data and paste this into your spreadsheet. Longitude is first. Convert text to columns, and now we have longitude, latitude, and elevation. Let's add some timing to the coordinate data. This will allow us to establish a sequence and some timing events as we animate the data. First, let's add a sequence. We're going to take the first record, add one. We're also going to copy down the description. Now let's grab the beginning and ending timestamp from the description data. You'll notice that the last 4 characters represent the time zone. In this case, no time zone has been recorded, and so it records as UTC. Google Sheets interprets that as a date timestamp. Now that we have a beginning and ending timestamp, let's infer the values for the timestamps for all of the other data points. To do this, we're going to create a formula. We're going to take the ending timestamp, subtract the beginning timestamp, and divide by the number of intervals. The number of intervals are equal to the total number of records minus the very first record. Now we're going to complete this formula so that that interval is added to each of the data points. So we're going to start by adding the time of the record above. Though you'll notice that these are relative cell references instead of absolute cell references. So we'll want to convert some of our terms here to be absolute cell references. To do that, we just add a $, but not to our last term because that's a relative cell reference to the value above. Let's copy that value and paste down. Now, if we've done our math correctly, the interval between each record and its previous record will be the exact same amount. Let's test that to be certain that we've done our calculation correctly. So we will take the timestamp, subtract the previous data point, and let's look at it in seconds so that it's easier to absorb. To do that, we'll take this difference and multiply it by the number of seconds in a day. 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. Our test is to ensure that the values are equal across the data set. And here we see that approximately 18 seconds passed between each GPS coordinate recording. Let's complete our data, and now let's replace our formulas with actual values. Now that we've gathered and prepared our data, let's work on visualizing that animated GPS track. We have our data, it's now tabular. We have a description that describes each segment of the line, a sequence of each of the records, an approximate date time, the date that the track was recorded, longitude, latitude, and in this case elevation is there, but it's all zeros. Let's open up Tableau. Okay, let's connect to our data. There's 2 demonstrations I'd like to show here. The first example to show is what does our data look like if we just use the KML file? Let's find out. We'll connect to data, connect to our spatial file. We're going to import the KML file that we exported from our Google timeline. We see that there are 2 types of data. One is point, one is line string. Now intuitively, we may just want to bring geometry into the page, but this will result in an error. Tableau doesn't like to mix the geography of points and lines. So let's first filter our data so that we're only bringing in lines. When you look at your timeline data, you'll see all of the locations plus the movement activities. In this case, it's motorcycling. There we go. We instantly have a line. For our use case though, we want to animate this line. When we highlight this mark, it's one single mark, it's the full line. So we can't animate the individual movement over the course of the day. That's why we have our tabular data. So let's look at bringing in our tabular data and seeing if we can animate this line. Now before proceeding with the second part of this demonstration, we have to go back to the data. There's been some lessons learned in the last few minutes. I paused the recording and discovered that the level of detail can only handle one item of detail for this animated track. I attempted to place two of our columns from our data source, the description and the sequence column, onto the detail and animate, and it doesn't work. We have to have a unique single dimension on the detail in order to animate this track. So I created a new column, called it the day sequence, and just added integers from 1 to n for all of the tracks in that day. Let's bring in this data source to Tableau and take a look. So we will connect to a new data source. It's a G sheet. Authenticate. And we'll go back to Tableau. The G sheet connector provides a list of all the recent G sheets. We'll connect. We're going to bring in our GPS tracks data with the new day sequence column. We'll extract and then build a worksheet. We have our fields. Day sequence is a dimension. Let's bring latitude and longitude onto the page. By default, it's aggregated up to one single mark, so we want to add detail. We can do this by adding things to the detail, or we can just page through the day sequence. Now we have several days of data in our data set, so let's also filter for a specific day. So we just want to filter for 9/12. Let's look at some of the history settings so that we'll show our trail. We want to show all, we want to show trails, and we want to format that trail so that it's a dotted line and it has a high contrast. Now let's set it to the highest speed setting and animate. Okay, it looks like that's finally animated. There we go, how to animate GPS tracks in Tableau Desktop.